Hello everyone and welcome to another video. In today's video, we're going to be starting to learn about calculus and specifically diving into the concept of derivatives. So, imagine you have a curve on a graph representing some function, let's say f of x. The question we want to answer is, how does this graph change, this curve change? Or even more specifically, how fast is the function changing at any given point? That is your derivative. The derivative of a function tells us the rate of change at any given point. In simple terms, it gives us a slope of the curve at that point. The steeper the curve, the greater the rate of change. Here's an important concept. The derivative at any point on the curve is the slope of the tangent line at that point. Think of a tangent line as a straight line that just touches the curve without crossing it. The slope of that line is the derivative. As a very simple example, if we have a graph here, where here we have our y-axis, and here we have our x-axis, our point 0, and we have a function that goes, for example, like so. This is our f of x. Then our tangent line would be at a specific point. Let's name it point P. Would be this one, where it only touches the curve of f of x at one point, which is this one, and our normal line would be the one perpendicular to our tangent line. This is our tangent line, and our normal line would be the one perpendicular, so the one like so. This is our normal line, perpendicular, 90 degrees, 90 degrees. There is a general formula for finding derivatives, which is f prime of x. This is the notation we use for our derivative. This is the derivative of f of x. F prime of x is equal to the limit of h approaching to 0 of f of x plus h minus f of x divided by h. That is our general formula for finding our derivatives of the function. So let's try and apply this to an exercise. Our function, our f of x, is equal to x squared. So now let's find our f prime of x, our derivative of x. Limit where h approaches to 0, f of x plus h. This is basically like so. F of x plus h would be equal to x plus h squared. So that's what we write here. X plus h squared minus f of x. F of x is just x squared. So x squared divided by h. This is equal to the limit of h approaching to 0 of x squared plus 2xh plus h squared minus x squared over h. This is equal to, we cancel this x squared with this x squared, which is finally equal to limit of h approaching to 0 of 2xh plus h squared over h. We have a common factor of h, so we can cancel these. Limit of x approaching to 0 is equal to h times 2x plus h over h, and we cancel these two. So we obtain that the limit of x approaching to 0 of 2x plus h. And then, since our x is approaching to 0, we just substitute it here. 2x plus 0 is equal to 2x. So, our derivative for this function, x squared, is 2x. Let's look at some simple concepts, some formulas that we can apply in order to solve these derivatives faster, instead of always having to apply our formula. So, if our y, or our function, is equal to k, so a constant, the derivative y prime is going to be equal to 0. A derivative of a number, 1,000,000, 0.72 is going to be equal to 0. If we have y equals to x, the derivative is going to be 1, or if it is minus x, it is going to be minus 1. If our function is k times x, so a parameter, a number times x, this is going to be k. And then if we have here ax plus b, for example, our derivative is going to be, the b cancels out since it's a constant, and we only keep the a, so we use this, and it stays as just a. There are other formulas as well, such as function is x to the power of n, and then our derivative would be y prime is equal to n times x to the power of n minus 1. So we had here x squared, this is just, or x to the power of 3, this would be 3x squared. Then if we have y equals to square root of x, our derivative is 1 over 2 squared of x. If we have here that our y is equal to logarithm of base a of x, then our derivative is going to be equal to 1 over x natural logarithm of a. And if we have that our y is equal to natural logarithm of x, our derivative function is going to be 1 over x. If we have that our y is equal to a to the power of x, then our derivative is going to be a to the power of x times natural logarithm a. If our y is equal to e to the power of x, our derivative is equal to e to the power of x. It remains unchanged. We have more formulas such as y is equal to sine of x, and the derivative of this is simply cosine of x. Y is equal to cosine of x, and the derivative of this is negative sine of x. And y is equal to tangent of x, and our derivative is y is equal to 1 over cosine squared of x. Then we have here some basic formulas or methods for some processes, and these would be y is equal to f of x plus g of x, and the derivative of this is simply f prime of x plus g prime of x. Same with a negative sign here. This would just be a negative sign over here. If we have y is equal to f of x times g of x, then the derivative of this is f prime of x times g of x plus f of x times g prime of x. If we have y is equal to k times f of x, our derivative is simply k times f prime of x. If we have that our function is f of x over g of x, so a division, our derivative is going to be f prime of x times g of x minus f of x times g prime of x divided by g of x squared. And finally, if we have a function of f of g of x, then our derivative for this is going to be f prime of g of x times g prime of x. And those are the formulas or methods to use for a process. These are all formulas that you should try to memorize, as instead of having to apply the formula of derivatives every time to solve a problem, you can simply apply this knowledge and solve it much faster and easier. That'll be all for today. Thank you for watching, and in our next video, we're going to be continuing to explain derivatives.